Welcome to Mathematics 10. Today we're covering the inverse trigonometric ratios. Before we start a lesson, there is some knowledge that you need to know. You need to know about the opposite, adjacent, and hypotenuse sides of a right triangle, given the angle. We also need to know the SOHCAHTOA ratios, the sine theta, the cosine theta, and the tangent theta. The objective of today's class is to use the inverse trigonometric ratios, the arcsine, the arccos, and the arctan, to find the measure of an unknown angle in a right triangle when I give you the two side lengths. Let's try the first example question. Find the measure of angle theta to the nearest degree. So in this case, I know that I have the opposite side given to me, and I have the hypotenuse side given to me. So, if I know the opposite side and I know the hypotenuse, which of the three ratios can I use? Well, I have sine, cosine, tangent, SOHCAHTOA. So the one that has the opposite hypotenuse must be the sine theta. We know that sine theta is opposite over hypotenuse. And we also know that the opposite is exactly 3. And the hypotenuse is exactly 5. This question is asking for the measure of this angle theta. So I need to undo the sign here on the left-hand side. Well, how do I undo a sign? Well, that's what we're learning today. We're doing the inverse trig ratios. And one thing that we know, that we should learn is that the undoing, the opposite of sine, is called the arc sign. You know, it looks kind of weird, it sounds kind of weird, but we just have to trust that the arc sign will undo the sine. In other words, my left-hand side will just be theta. The arc sine and the sine, they're opposite of each other, so they cancel each other out. Just like how minus 2 undoes plus 2. Divided by 3 undoes times 3. Arc sine undoes sine. Well, what about the right-hand side then? The arc sine of 3 over 5. So this is where we need to use a calculator. So take out your calculator. And I'm going to do arc sine of 3 over 5. Usually, on your regular scientific calculator, you need to press the second button and then press sine. That's where you see the sign with a -1. Or if you're using the Desmos, you want to press the function, and then just below the sign, you see the sign with a -1, the inverse trig functions. Anyways, I'm going to do arc sine of 3 over 5, and I get 36.8698, blah, blah, blah. So I'm going to round it as 36.9 degrees. So theta is approximately 36.9 degrees. And that is my final answer. Just make sure that you're using the degree mode, not the radian mode. Radian mode, we'll learn it later. So let's annotate my process here. The first thing that I do is I want to identify the sides of the triangle. After you identify the sides of the triangle and identify the ratio, the trig ratio to use. After I identify the trig ratio to use, you plug in the numbers, 3 and 5 in this case. And then we did arc sine. By the way, the arc sine, we can also write it as sine with a -1 on the top like this. I don't really like that notation, but it's commonly used on the calculators. Arc sine both sides to undo the sine. after we undo the sign on the left-hand side, well, you're left with the arc sine of 3/5 on the right-hand side. So we use calculator to find the approximate number for arc sine of 3/5, which turned out to be 36.9. Let's do the second example question. Find the measure of the angle x to the nearest degree. Well, same thing. We're going to start by identifying the sides of the triangle. In this case, the x is on the bottom right-hand corner here. So the 5 in this case is the opposite side. And the 12 here is the adjacent side. So I know the opposite, I know the adjacent, and I want to know the angle. So which trig ratio should I use? So, ka, toa. The one that has the opposite and adjacent is tangent. So I'm going to use the tangent ratio in this question. Tangent of x is given as opposite over adjacent. The TOA, the TOA is finished there. And I know the opposite is 5. And I know the adjacent is 12. Now, I need to solve for x. I need to isolate the x, which means I need to undo the tangent on the left-hand side. How do I undo the tangent? Undoing the tangent, well, you've never heard of it, but we just need to put arc at the front. So we need to do arc tan. The arc tan will undo the tangent. Let's just do the arc tan on the other side as well. Arc tan of 5/12 as well. Arc tan of tan of x, well, arc tan and tan, they cancel each other. So that's just going to be x. On the right-hand side is arc tan of 5/12. Now, take out your calculator. And let's do arc tan of 5/12. So make sure you find a tangent with a little -1 on the top right-hand corner. And for me, it turns out to be 22.6 degrees. So I'm going to write as x is approximately 22.6 degrees. Let's annotate our work. First, once again, you identify the sides of the triangle. And then identify the trig ratio to use. In this case, I knew the opposite, I knew the adjacent, so I know that I have to use the tangent ratio. Undo tangent by arc tan on both sides. Once again, the arc tan can be written as tangent with a little -1 on the top right-hand corner. Then I use the calculator to find the approximate value of arc tan of 5/12. So in today's video, we talked about the inverse trig ratios and how we use them to find the unknown angle of a triangle. So inverse trig ratios is an operation that they undo a trig ratio to find the angle. On the calculator, we usually use the second or shift. It's usually color-coded in different ways. And then we press the respective sine, cosine, tangent button and to access the arc sine. For notation, we either use the arc sine or sine to the power of negative sine with a -1, arc cos or cos with a -1, arc tan or tan with a -1. And we use them based on which ratio that we're using. And make sure that on the calculator, you're using the degree mode, not the radian mode. The radian mode we will cover in pre-calc 12. So thank you for watching this video, and I'll see you in the next one.